Good morning, everybody. So, how was your exam yesterday? Did you score like as much as you were expecting? Okay, good. Like, keep on improving, okay? Like, just make sure that every mock test you are improving. Your score is not decreasing. So, that's why we are doing paper discussion also. And coming to physics, there were like 45 questions. How much did you score in physics? Like, is it like 50% did you score? 50% means? Like, can you get 100 in physics? Is that possible? Around 25 questions you should make correct then. 70. Okay, good. That's a good score. Okay, if you don't want to say, it's fine. We will discuss, okay? No problem. Now, coming to physics, we can say that the questions were like on the easy part more, okay? Easy questions were more, which means there were no like much calculations required to answer them. Okay, such questions were lot were there. Let's see which were they. First one, a particle moves under the effect of a force F equal to Cx and from x equal to 0 to x equal to x1. Work done in the process. We know work done equal to f dot dx. So total work done will be integral f dx. Okay, from where? 0 to x1. If you substitute that, you will get c x1 square by 2. Work done equal to, this is 2. So answer is option B. I hope everybody made this correct. Very easy question. Okay. Okay, good. Then coming to next one. A mass m is split into two parts, m and m minus m, which are separated by certain distance. What ratio of small m by capital M maximizes the gravitational force between two parts? Okay, whenever you want to find a maximum or minimum of something, you already studied in 12th differential equations. Okay, so if some people have not taken max, please listen. If you want to find a maximum or minimum of something, you have to find differentiation and equate it to 0. Okay, so gravitational force maximum we have to find, right? So gravitational force is equal to G m1 m2 by, let's say the distance between them is d, so d square. This will be gravitational force. Now we have to find differential, but with respect to what? We have to find the ratio of m and m, right, to find maximum. So we have to find differential of f with respect to the variable m, df by dm. Okay, if you do that, you will have g by d square is constant, then d by dm of, inside if you take capital M, m minus m square. Okay, differential you will get as g by d square into capital M minus 2m. Now if you equate it to 0, g by d square won't be 0 because they are constants. Then you will get that capital M minus 2m equal to 0. So m equal to 2m, which means m by m will be equal to 1 by 2. So answer is option B. Is that clear? Okay, so whenever you want to find a maximum or minimum of something, find differential and equate it to 0. With respect to what variable you have to find, like whichever ratio is asked or whichever is asked in the question, based on that variable you have to find the differentiation. Okay. Coming to next question. I hope there is no doubt in this. Coming to next question 3. The power of lens is given as 1.25 per meter inverse. In particular medium, refractive index of the lens is 1.5 and radius of curvature are 20 cm and 40 cm. Refractive index of surrounding medium. Okay. So our equation is this: 1 by lens maker's formula, mu of material divided by mu of surrounding minus 1 into 1 by R1 plus 1 by R2. This is our lens maker's formula. 1 by F is given, that is 1.25. 1 by F is our power, right? So power is given. You just have to substitute R1 and R2 in terms of power. R1 will be equal to 0.2 meter, R2 will be equal to, see, R1 will be on the, it is given convex lens. So R1 will be plus and R2 will be minus 0.4 meter. Substitute this, like refractive index of medium is also given. You have to find mu s. It is like lengthy. It like multiple steps will be there on solving for mu s, but it is direct formula application only. Can you calculate? Is there any doubt in this one, the formula? We are directly taking lens maker's formula. 1 by F is given, power, R1, R2 given, refractive index of medium given. Substitute it and you will get the answer 9 by 7. Okay. Did you understand, or is there any doubt in question number 3? Okay, moving on to question number 4. Which of the following is incorrect? Okay, we know that acceleration is not equal to v into r. Okay, this is our normal acceleration, that is not v into r. V equal to omega cross r, that is true. Alpha equal to d omega by dt, that is also true. So the answer is option B. A equal to V cross R is not correct. Okay. Any doubts? So as you can see, all these questions had like option B answer. Maybe it's a pattern. But I have seen that in some videos they will say you keep on clicking, like choosing B, at least like half will be correct. No, please don't do that. This is like sometimes there will be a pattern. Okay. Now next one, question number 5. 2 point charges plus 8q minus 2q at x equal to 0 and x equal to L respectively. The point on x axis which the net electric field is 0 due to these charges. Okay. So plus 8q is at 0, minus 2q is at L. Okay. Now if you take any point in between them, okay, if you take any point between them, what happens is that minus 2q, this is minus 2, okay, minus 2 will attract it and plus 8 will repel it. So both electric field will be in same direction. Okay, so it will not cancel out. For electric field, net electric field to be 0, it should cancel out, right? So it should be in opposite direction. So in between them it won't cancel out. Now if you take this side, okay, in this side it might cancel out because plus 8 will repel and minus 2 will attract. But since minus 2 is the lesser charge, as we go far away it will reduce. So it will not have enough strength to cancel out plus 8. So the point will be on this side. Okay, and both should cancel out. Without all this we can simply equate force due to plus electric field due to plus 8q will be equal to electric field due to minus 2q. Just substitute this, you will get the value of R. Okay, so from this you will get K 8q divided by this distance will be, let's say, r. R square will be equal to k 2q, minus sign is not required, sorry, because we are directly equating, k 2q divided by, so this distance will be what? R minus L, r minus L the whole square. Q and k will get cancelled on both sides, then cross multiplication, you will get a quadratic equation. And to solve quadratic equation, you know how to solve, minus b plus or minus, that one you can use, or completing the square method you can use, whatever method you can use and find what will be r. Is there any doubt in the method? Can you hear me properly? Okay, so I hope there is no doubt in this, and you will get the answer r equal to 2L. Okay, like from this you will get a quadratic equation. When you solve the quadratic equation, you will get what is r. That's it. Now next is potential energy of a system of two charges is negative. Potential energy is equal to, potential energy equation is equal to k q1 q2 by r. We need u to be negative. Okay, q1 and q2 positive, u will be positive. q1 and q2 negative, still u will be positive. If q1 is positive and q2 is negative, then u will be negative. So answer is option C. Okay, both charges separated by infinite distance, there will be no potential energy, it will be 0. Okay, so I hope you understood this. Potential energy direct formula, q1 and q2 both positive, u positive, q1 q2 negative, u positive, but one positive, one negative, you will get energy negative. Can we move on to the next question? Okay. Coming to next question. An electric fan and heater are marked as 100 watt, 220 volt, 1000 watt and 220 volt respectively. Resistance of the heater. What is the power of, what is the unit of power? Okay, so power we can find using V square by R, one equation. Another equation is V into I. Another equation is I square R. Here they have given us V, like voltage they have given. They are trying to find the resistance. Okay, so we will use the first equation, P equal to V square by R. Since voltage is same for both and power is more for heater, then what can we say about resistance of fan and heater? V is same for both. Power is more for heater. So resistance should be less there, right? So resistance of heater is lesser than of fan. Option B is the answer. Okay, is it clear? See, these kind of questions, there is no numerical. We don't have to calculate anything. We just need to know this formula. That's it. Okay, I hope we can move on. This one might be confusing and it might be a little bit hard one. Okay, coming to two waves are represented by the equations y1 equal to a sin omega t kx plus 0.57 and y2 equal to a cos omega t plus kx, where x is in meters, t in second. What is the phase difference between them? So when you represent a wave, okay, y equal to a sin omega t plus k plus or minus kx, leave it, plus phi. Okay, this phi is phase of that particular wave. So y1 is having phase phi1 equal to 0.57. Coming to y2, it is given in cos. So we have to convert it to sine to get the phase for this one. Okay, converting it to sine, you will get y2 equal to a sine pi by 2 plus omega t plus kx. Okay, sine pi by 2 plus omega t, complementary angle sine and cos. So phase of y2 is equal to pi by 2, 90 degree. Now since both will be in radian, you can find delta phi equal to phi 2 minus phi 1. Substitute pi equal to 3.14 by 2 and this will be equal to 3.14 by 2 minus 0.57. This you will get as 1 radian. Answer option A. Is there any doubt or any confusion regarding this? No. Okay. So moving on. Two identical thin bar magnets of each of length L and pole strength M are placed at right angles to each other, with the north pole of one touching the south pole of other. Okay. Then magnetic moment of the system. Okay. Magnetic moment capital M is equal to M into L. And what is the direction of it? It will be from south into north. So one will have in this direction, another will have in this direction. Okay. Now net magnetic moment, two are perpendicular to each other. So net magnetic moment will be root of ml square plus ml square. Okay, since they are perpendicular to each other, this you will get as ml root 2. Answer option C. Any doubt? Okay. So moving on. Next, again we don't have any numerical thing here. Dimensional analysis can be applied to A. Check the dimension consistency of the equation. Dimensional consistency means, I told you when we were studying units and measurements, like LHS and RHS should be of same dimension, and if you are adding something, both should be of same dimension. So we can use this. Then next one, deduce relations among the physical quantities. And for we also said that, like, if there is like one time period proportional to some force and velocity, we can find the what is that relation between them. So this is also true. Third one, to convert from one system of units to other, that we did practice one question, like units are given in like MLT, fundamental system, but if fundamental units are changed to force, pressure and time, how will you convert? That also we can be done. So answer is all of this. Dimensional analysis used for all of this. Okay. This one we already saw the equation for this. Okay. A body covers 26-28 meters in 10th and 11th second. So in 10th second, from 9 to 10 when it is going, it is covering 26 meters. 10 to 11 when it is going, 28 meters. The body, like, what is the situation of body, initial velocity or acceleration, all these things. So at nth second distance covered, formula is u plus a into n minus 1 by 2. Okay, this is the formula. Okay, so using this formula, n is time, okay, which 10th second. If 10, then you have to substitute here 10. So 26 equal to u plus a, u and a we don't know, into 10 minus 1 by 2. 28 is equal to u plus a into 11 minus 1 by 2. Substitute that and you will get 26 equal to u plus a into 10 minus 1 by 2. 28 equal to u plus a into 11 minus 1 by 2. Okay. Now you can cancel u from both of this, right? If this is 2 and this is equation 1, if 2 minus 1 you take, you can cancel u and you can solve for a. Okay. Like that, when you solve for a, you will get a equal to 2 meter per second square. You can try that. Okay. Use these equations, 2 minus 1. Similarly, once you find a and you substitute in this equation, you can see what is u. U equal to 7 meter per second, which means there is a initial velocity and there is uniform acceleration. So it is not starting from rest. So a and b not. It is starting with an initial velocity and moves with uniform acceleration. That is the answer. Okay. Is that clear? Equation for nth second, that is the formula we are using. Okay. Coming to next question. A particle moving with a velocity v equal to this, where k is a constant. General equation for the path. Okay. Path equation, y equal to x something will come. That we have to find. Usually we will get y like velocity as a velocity as a function of time, but here it is y and x. So what we will do is, v velocity is equal to vx I cap plus vy j cap. Okay, this is the general way how we write. From comparing to this, we will get that vx is equal to ky. This is nothing but dx by dt. Okay. Now vy is equal to kx and this is dy by dt. Now if you want dy by dx, so dy by dx if you are finding, this will be 2 by 1. 2 by 1 if you do, you will get dy by dx. That will be equal to x by y. Now cross multiplying, you will get y dy equal to x dx. Now just integrate on both sides. Our formula will be y square equal to x square plus c. Okay. Any doubts? Like on integrating on both sides, you will get y square by 2 plus y square by 2 equal to x square by 2 plus some constant c. Now you can like multiply with 2 completely, so it will become y square equal to x square plus 2c. 2c again, it's a constant only, right? So we can write it as plus c. That's how we get answer D. Is that clear? Okay, moving on to next question 30. 3 infinitely long parallel straight current carrying wires A, B and C are kept at equal distance from each other. Wire C experience force F. The net force on wire when current in wire A is reversed. Okay, so let's see that at C net force, how we can find F net will be equal to force due to B plus force due to C, right? Like vector addition we have to do. How to find force? This is from magnetostatics. So current carrying conductor, it will create a magnetic field. Then because of magnetic field B and current I, you will get a force. So force due to B will be BIL. This is the equation. Here instead of taking L, we can say force per unit length we can calculate. Okay, that also no problem. Now for calculating this, for B, current is in upward direction. So if you use right hand thumb rule, okay, current along thumb, so fingers will give you direction of magnetic field. So magnetic field due to B will be into the page. Okay, magnetic field due to wire B will be into the page. Here in this case, first case, magnetic field due to this current will also be into the page. Okay, due to A. Now if you are finding net, you will get that mu naught I from B into IC divided by 2 pi distance between them, let's say it is R, so 2 pi R. Since both magnetic field are into the page, force will be in the same direction, because force equal to B cross L. So B is in inward direction, then L is in L we will take as a direction of current only. So B cross L you will get force repulsion. Okay, plus mu naught IA into IC divided by 2 pi, distance will be 2R. So 2 pi into 2R. This is given as F. Okay, actually we don't need this, but for understanding I am telling. Now in the this is first case. Now coming to second case, how it will be? F net equal to, due to B there is no change in magnetic force, so it will be mu naught I square by 2 pi R. Now due to A, it will be in opposite direction, right? So if you take that, you will get minus, force will be in opposite direction, mu naught I square into 2 divided by 2 pi into, this is 2R, sorry, 2 pi into 2R. Okay, so 2 will get cancelled, both are same, so final force will be equal to 0. Option A is the answer.
Madam, in second case once again.
Which one? Second case. Second case, due to B there is no change in force, right? But reverse, current is reversed in A. So current is in this direction, magnetic field will be out of the page. Magnetic field out means the force direction will also be opposite, right? So instead of adding, we will minus that force. Due to B it is in one direction, due to A it is in opposite direction. So F force due to A minus force due to, this will be force due to B minus force due to A. That's it. Same equation as in one, but instead of adding we will minus since the direction is reversed.
Okay ma'am, thank you ma'am.
Okay. Dheeraj, is it clarified or do you want to repeat? Okay. Okay. Force we are calculating using BIL formula. Let's say we are adding L also, no problem. Force equation will be B mu 0 I by 2 pi R due to straight wire into I, that is I of C. So force due to B will be mu 0 IB by 2 pi R into IC. Similarly, force due to A will be magnetic field due to A into current in C. Okay, so mu naught A by 2 pi, distance between A and C will be 2R. Okay, so 2 pi into 2R. This is equal to our force F initial given. Next, how we are calculating adding or subtracting, that is depending on direction of magnetic field. So if wire is carrying current in upward direction, we place thumb in upward direction and the fingers will give direction of magnetic field. So first case, B and A both are having magnetic field into the page. So we can, the force due to them will also be in same direction, we can add them. In second case, current is reversed. So current is going in downward direction, due to A, magnetic field will be out of the page. So B, there is no change, still it is into the page. Due to A, it is reversed. So we have to minus the force of A from B in the second case. We are directly substituting in BIL formula only, but here you can see 2 will get cancelled. B, force due to B will be equal to force due to A, so final force will be 0. Is it clear now? Okay. Coming to next question. The RMS value of an AC current is given as 50 Hertz is 10 ampere. RMS current is 10 ampere and frequency of that current is like 50 Hertz. Time taken by alternating current in reaching from 0 to maximum value and the peak value of current will be. So this is our like AC current, right? From here to here, this much time is equal to time period T. Okay, and they are asking from 0 to maximum value. So this much time we have to calculate. This will be T by 4. How to calculate T? Time period T is equal to 1 by frequency. Okay, time period equal to 1 by frequency. Frequency is given, just substitute here, then you will get T divided by 4. You will get what? The first one. Now peak value of current also you have to find. Peak value of current, I peak will be equal to, we have the formula I RMS equal to I naught, that is peak value by root 2. So RMS value into root 2 you will get peak value. Root 2 1.414 into IRMS 10. So maximum current will be 14.14 ampere. Doing this you can calculate T also. So what will be the answer? 1 by 4 into 50, that will be 1 by 2. So answer will be option D, 5 into 10 to the power minus 3. Is that clear? Is it clear for all? Just give a thumbs up or we can move on. Did not understand, okay. I RMS value is given. I RMS have equation I naught by root 2. So I naught is peak value will be equal to root 2 into I RMS. This is given as 10. Root 2 value is 1.414. Okay, into 10 you will get as 14.14 ampere. Okay, this is I naught. So either this is the answer or this is the answer. We can confirm which is the answer by calculating T. They are asking time from 0 to peak value. This much time is T by 4. Okay, because total is time period, this much time will be T by 4. T is equal to 1 by F. So T equal to 1 by F. So T by 4 will be equal to T by 4 can be written as 1 by 4 into frequency, that is equal to 1 by 4 into 50. 4 into 50, 200. 1 by 200 if you are calculating, you will get this 5 into 10 to the power minus 3. Okay, now clear? Okay. Next question, magnetic flux linked with the coil is given. Induced EMF in coil at time t equal to 4. Very direct application of formula. Induced EMF equal to minus d phi by dt. Directly finding differentiation, you will get minus of 2 into 5t plus 3. Okay, and t is given as 4 seconds. Just substitute 4 there. So 40 plus 3 minus 43 volt. answer. Is that clear for all? Direct formal application only, there is no change. Okay. Next one, a particle undergoes simple harmonic motion having time period t. Okay, this one is a bit I will say in a hard region, okay, not easy or medium, it will be little hard. A particle undergoes simple harmonic motion having time period t. The time taken in 3/8 oscillation is. So now as you can see, when the question is lengthy, means question for reading it is lengthy doesn't mean the actual, like our part will be lengthy. Answer is not lengthy, it will be very simple. But sometimes you see it has only one line. You might think okay I will attend it, but it will be a lengthy question. Okay, so don't judge the question by the length of the question. Okay, coming to this, we have time period t. So if it is starting from middle oscillation, it will go to extreme position, then come back, then go here, then come back. This is for time t. Okay, now if I am taking 1/8, okay, so it is going 1, 2, 3, 4. So from 0 to maximum position, this will be 1/4. 1/8 will be half of that, right? So from 0 to half of this, a/2, not a/2 actually, half length will be considered as 1/8, amplitude by 2. This is 1/8 oscillation. Now equation for SHM x equal to a sin omega t. Okay, x is given as a/2. a/2 equal to a sin omega we can write as 2 pi by time period t into t. Okay, now a will cancel. Sine of 2 pi t by capital T is equal to 1/2. So when is sine equal to 1/2? When it is equal to sine 30. Okay, so from that we can say that 2 pi t by t is equal to 30 degree, or in radians it will be pi by 6 radians. Okay, pi cancel. Now if you want to find t will be equal to capital T by 12. So for 1/8 oscillation, time taken is t by 12 seconds. Okay, but for 3/8 it is not equal to 3 into 1 t by 12. No. For now we have to find 3/8, right? 3/8 means 1/8 plus 1/8 plus 1/8, coming till here. From 0 to maximum value, it will take t by 4 seconds. And from here to here, it is taking t by 12 seconds. So from here to here, how much time it will take? T by 4 minus t by 12 will be equal to, from this point to this point, time taken. Calculating this, you will get 2t by 12. Okay, this is time taken from here to here. Now t by 12 plus t by 2t by 12 plus 2t by 12, that will be 3/8 of the oscillation. Add all these, you will get the answer. It will be 5/12t. Are you understanding? Like, okay, good. Okay, adding all this, you will get the answer 5/12t. And okay, that's why I said this is a bit lengthy one. Now coming to question number 17. Two balls are projected simultaneously in the same vertical plane from the same point with velocity v1 and v2 with angle theta 1 and theta 2. V1 cos theta 1 equal to V2 cos theta 2. Then path of one ball seen from the position of other ball. This is basically relative velocity. Okay, but you don't have to calculate anything. V1 cos theta 1 equal to V2 cos theta 2. Okay, this is basically projectile motion. From some point, from some height, one object is thrown with initial velocity v1 and theta 1. Another object is thrown with theta 2 and v2 velocity. v1 cos theta 1 equal to v2 cos theta 2 means this is their horizontal velocity. Okay, vx1 equal to vx2. If two things are thrown simultaneously and have same horizontal velocity, it will go like this. Okay, both will have same x position at the same time. So when you look from one ball to the other ball, what will happen? It can only move in vertical direction. Okay, because in horizontal both are moving together. So according to ball A, ball B is not having any horizontal motion. It will only have vertical motion. So answer is option C, vertical straight line. Is it clear? Okay, so we can move to the next question then. This one is really easy, so if you are not attending such questions, it might be a waste. For the given situation shown in the figure, find the value of theta for equilibrium. Okay, as we told you, this is T1, so this will be T1 cos theta 1, and in this direction there will be cos theta, only one is there. T1 cos theta, and this will be T1 sin theta. Okay, now for equilibrium we just have to equate vertical ones. So T1 cos theta equal to T2, that is equal to 60 Newton. Okay, this length 2 meter and all are given like simply, we don't have any use for it. Okay, W is 60 Newton, T2 60 Newton, here also T2 60 Newton, and T1 sin theta is also opposite to 60 Newton. Now sin theta by cos theta, if you take tan theta equal to 1, so theta will be equal to 45 degree. That is the answer, option B. Okay, really easy question. I hope there is no doubt in that. Next, question number 19. If the wire in experiment to determine resistivity of a material using meter bridge is replaced by copper or hollow wire, balance point will be. So meter bridge, let's check the equation. For finding unknown resistance, equation is R into L by 100 minus L. Okay, we are only considering L and 100 minus L, and there is no, like the meter bridge wire, it is not coming anywhere, right? Exact resistivity of that. So whichever wire you can use, it will depend on X and R only, balancing point. Therefore at the same point is the answer. Voice is breaking. Wait, is it for everybody or like? Is the audio video not good for anyone? Okay, it's fine. Okay, so basically it depends only on unknown resistance and known resistance we are keeping, and the actual wire of meter bridge will have no like contribution to that, so balancing point will not change. Next, question number 20. A body of mass m is accelerated uniformly from rest to speed v in time t. The instantaneous power delivered to the body as function of time. So you have to find power. Power is equal to force into velocity. We discussed this formula. And force can be said as mass into acceleration into velocity. Velocity, if I am writing in terms of acceleration, it will be m a square t. Velocity will be acceleration into time. How? V equal to u plus at. Since it is starting from rest, u equal to 0, so v equal to at. Okay. Now acceleration, if you are finding from 0 to v in time t. Okay. So acceleration we can say as acceleration equal to v by capital T. Okay. So this will be m v square t by capital T. Answer. Option A. Sorry, v square t square. Two options are there, right? Either one you can choose. Both are right. Okay. Sorry, that is t square, so not. mv square t by capital T square. Now if VE is the escape speed from Earth and VP is from a planet having half radius of Earth, density of both planets same. What is the relation between VE and VP? Since we already completed gravitation chapter, you should attend this. Escape velocity of Earth is equal to root of 2g mass of Earth divided by radius of Earth. Escape velocity of planet P will be root 2g mass of planet P divided by radius of planet P. Now both we have to write in terms of mass of Earth and radius of Earth. So mass of planet P will be equal to density of planet P into 4 by 3 pi rp cube. Okay, this will be mass of planet P. Since density is same for both, this I can write as density of Earth into 4 by 3 pi. Radius of planet is half of radius of Earth. So radius of Earth cube divided by 8 by 2 cube. Okay. Density of Earth into volume of Earth, this will be. So this will be mass of Earth by 8. And Rp is already given, Rp equal to Re by 2. Substitute that and you will get the relation VE equal to 2Vp. Is there any doubt? Okay. Coming to next question. Length of metal L1 is length of a metal is L1 when tension is T1, L2 when tension is T2, the original length of the wire. Okay. So this is from Young's modulus of elasticity. So delta L1 we can calculate as force of first one into L0 divided by area into Young's modulus. Okay. Since this L0 AY, this much L0 by AY, all are constant values, this we can say as some constant K into F1. Force 1 is tension. So L1 is equal to L0 plus delta L1, that I can write as delta L1 equal to K into tension 1. L2 is equal to L0 plus K T2. Okay, since K is same in both, L1 minus L0 by T1 equal to K is same as L2 minus L0 by T2. that is also K. On solving this, you will get the value of L naught. Cross multiply and equate for L naught. You will get L naught equal to L1 T2 minus L2 T1 divided by T2 minus T1. Okay, is there any doubt? Is it clear for all? Okay. Moving to next question. Two coils of self-inductance L1, L2 are given, placed so close together that the effective flux in one coil is completely linked with other. Mutual inductance. So, mutual inductance you can find using relation M equal to root L1, L2. If K equal to 1, we are assuming K equal to 1, then M will be equal to root L1, L2. You can directly find the answer. 2 into 8, 16. Root 16, 4. 4 mH. Okay. Is there any doubt in question 23? That is direct formula question only. Next one, let R be the distance of point on axis of a bar magnet of length L from its center. Magnetic field at such point is proportional to. Okay, so bar magnet can be considered as a dipole. Okay, for dipole, field is proportional to, let's take for electrostatics, electric dipole or magnetic dipole, field at in point will be proportional to 1 by r cube. Okay, if it is a point charge or single pole, it will be 1 by r square. Since it is dipole, it will be 1 by r cube. Okay, is there any doubt? Okay, next one, graphical question. Which of the following curves is variation of impedance with the frequency? Okay, impedance equation, Z equal to root of r square plus xc minus xl the whole square. Okay, when the frequency is low, like xl is more. When frequency is high, when frequency is low, xc is more. When frequency is high, xl is more. Okay, so both cases value of impedance will be high. Now if you take R will not change with frequency, but when xc is equal to xl, that resonance condition, it will cancel out, it will just be R. So resonance condition, it will be impedance will be minimum. So only one showing minimum is this one. So this is the answer, option C. Okay, is there any doubt? Did not understand. Xc and XL formula you know, right? C omega, then 1 by C omega and L omega. So when frequency is less, in the less region, Xc is more. So this value is high. Okay, and as we increase the frequency, its value will decrease, its value will increase. Okay, so total impedance will start decreasing. Then at one point both will be equal. When both will be equal, that is our resonance condition where impedance is minimum. So minimum is like only one graph is showing a minimum value, so that we can consider as answer. Then as frequency increases from minimum point, then what will happen? XL will start increasing, XC will decrease. So again the total impedance will increase. Okay, is that clear? I think Dheeraj was okay. Moving on to next question. Electromagnetic waves travel in a medium at speed this. Relative permittivity of the medium is 1. permeability of the medium is 1, relative permittivity we have to find. This is the formula we have to use, C equal to 1 by root mu naught epsilon naught. So V equal to 1 by root mu of medium into epsilon of medium. Then C by V will be equal to root of mu by mu naught epsilon by epsilon naught. This is our relative values. Okay, this is equal to relative permeability into relative permittivity. Mu r is given as 1, C we know is 3 into 10 to the power 8, V is given in the question, you can find epsilon r. Okay, what will be the value? Like it will be 3 by 2 the whole square. Okay, basically 3 by 2 the whole square, that will be 9 by 4, 9 by 4 you have to find 2.25 answer. Okay, next one. This is a conceptual question. Two wires of same material are hanging in the shown figure. Breaking stress is equal for both wire. Okay, now this is wire 1 and this is wire 2. Even though in figure it looks similar, its length may be different. Okay, L1 and L2 may be different. Area also different, A1 and A2. Okay, breaking stress is same means stress is equal to force by area. Okay, so F1 by A1 is equal to F2 by A2. Both stress is same, but both will break at different forces. Okay, first one, if mass M2 increases, upper wire will break first. We cannot say that, because upper wire may have like larger area, so it can have like it can take more load also. So assertion is wrong. Then reason, breaking load of two wires of same material can be different. F1 F2 load is different, right? So it can be different. This is correct. Answer is, assertion is false but reason is true. Okay. Okay, next, moving on to next question. Next, 28, this is from thermodynamics and like calorimetry also included in this. 1 gram of water at pressure, this value is converted to steam without any change in temperature. Volume of 1 gram steam is given, latent heat of evaporation is given, change in internal energy. Okay, we know from first law Q equal to delta U plus work done. Work done can be considered as P delta V. If you want to find change in internal energy, that is nothing but Q minus P delta V. Pressure is given. Okay, volume of steam is given, volume of water is also given. So you can find change in volume. Now to find Q, Q is nothing but like heat is given for phase change, right? So Q is equal to mass which is converted into latent heat. Okay, so you can substitute ml minus P delta V. Substitute, all these values are given. Mass is given 1 gram, latent heat is given, then P is given, delta V you can find. Okay, and you will get the value as approximately 500 calories. Okay, is there any doubt? Okay. Next one, basic difference, assertion reason. Basic difference between various type of electromagnetic waves lies in their wavelength of frequencies. So all the like electromagnetic waves, they differ in frequency or wavelength. Reason, electromagnetic waves travel through vacuum with the same speed. That we know. All EM waves have same speed c in vacuum. So C equal to nu lambda is our formula, right? C equal to nu lambda. Since C is constant for all, frequency and lambda should change for everyone, like every wave. That's why both are correct, and reason is the correct explanation of assertion. Okay, without any change in temperature. Yes, like phase change means temperature won't change. That's why usually the formula for Q is equal to ms delta T, mc or okay. Since temperature change is not there, we can say that it will be latent heat, phase change only, m into L. If temperature change is there, we use this formula. And phase change also occurring, we will say total Q will be equal to ml plus ms delta T. Like temperature U equal to 0 for isothermal. It is not an isothermal process. Like U equal to 0 when, in which case for gases. Okay, for if you are just considering gases and without without temperature change a process is happening, delta U will be 0. But see, like from water to steam conversion, there even though temperature change is not there, internal energy change will be there. Okay, because latent heat is there. Now is it clear? Okay, I hope 29 question nobody have any doubt. Coming to 30, a gaseous mixture of 16 gram of helium and 16 gram of oxygen, ratio Cp by Cv. This one direct formula we got, that is gamma equal to gamma of mixture. Okay, gamma of mixture equal to N1 Cp1 plus N2 Cp2 divided by N1 Cv1 plus N2 Cv2. Okay, Cp by Cv is gamma, so for the mixture we have to find. Now N1, N2 is number of moles. Number of moles. Helium atomic mass is equal to 4. Okay, so 4 gram is 1 mole. 16 gram means 4 mole. So N1 equal to 4. Helium is having 4 moles. Oxygen O2 molecule having mass what? 32 U. So 32 gram of oxygen is 1 mole of oxygen. 16 gram of oxygen, half mole of oxygen. This is N2. Okay, N1, N2 we got. Now to find Cp and Cv. Cv is equal to F by 2 and Cp is equal to F by 2 plus 1. F depends on like F is degree of freedom. For helium is a monoatomic molecule. Monoatomic molecule, F equal to C, 3. So Cv1 equal to 3 by 2. Okay. Similarly, Cp1 is equal to 3 by 2 plus 1, 5 by 2. Okay. Now for oxygen is a diatomic molecule. For diatomic molecule, F equal to 5. So Cv2 is equal to 5 by 2, Cp2 is equal to 5 by 2 plus 1, that is equal to 7 by 2. All values are here, you can substitute and find the answer. Is it clear? Answer is option A, 1.62. Okay, this is how we are calculating. From number of moles we have to calculate first, then Cp and Cv with respect to these equation, F by 2 R. Okay, F by 2 plus 1 R is there, sorry. Using this you can get the value. R will get cancelled out, that's why I did not write R, sorry. So I think we can move to the next question then. Is there any doubt?
Ma'am, CP1 value.
CP1 5 by 2 R. Like F by 2 plus 1 R is CP. Okay. For monoatomic molecule, F equal to 3. So 3 by 2 plus 1 equal to 5 by 2. Clear? Okay. Coming to next, match the column. Okay. Choose anything which you know clearly. If you take torque we know it is R cross F. AQ. Okay. Out of all the options, only one option is having AQ. So that will be our answer. Okay. Sometimes it will be that simple. Sometimes it will be difficult. Then you have to calculate for other also. Is it fine? Should I explain others or can we move to the next question? Okay. Then coming to question 32. Light of wavelength 6.5 into 10 to the power minus 7 is made incident on two slits 1 millimeter apart. So lambda is given, small d is given, distance between third dark fringe and fifth bright fringe on a screen distance 1 meter. This is capital D. Young's double slit experiment that you understood from till now. Okay. So bright fringe and dark fringe, difference between that you have to find. So for bright fringe, xn equal to n lambda capital D by small d. And for dark fringe, xn is equal to 2n minus 1 lambda d by 2d. These are the formulas. Direct formula application only. When lambda is given, capital D, small d given. N for this is for bright fringe, right? Bright, which one? Fifth one we have to take. So xn equal to 5 lambda d by d. Similarly for dark, this is bright, dark one which we are taking third. So 3 into 2, 6 minus 1, 5 by 2 lambda d by d. Okay. Now substituting the values of lambda and everything you can do at last. Don't substitute here, find x bright, x dark and all. Do all the substitution in the last possible step only. When you find the difference of bright minus dark, you will get it is 5 lambda d by 2d. Okay. Then substitute the values in the last step. Then you will get the answer. Okay. Is there any doubt? Answer is 1.625 millimeter. Is this clear for all? Okay. Moving on. In a photoelectric effect measurement, the stopping potential for a given material is found to be V naught when radiation of lambda naught is used. If radiation is 2 lambda naught, then what will be stopping potential? How to find the formula is stopping potential into E is equal to hc by lambda naught minus phi. Phi is our work function. Okay. This is from the first. Okay. Second one we have to find E V dash is equal to hc by 2 lambda naught minus phi. We don't know what is phi. So from this we can find that phi, from this phi equal to hc by lambda naught minus E V naught. This we will get. Substitute phi here and you will get value for V dash. Is there any doubt? Answer is D. Is there any doubt for this? If not, we will move to the next question then. Okay. Next one, figure shows liquid flowing. This is from equation of continuity. We are not covering fluid dynamics, but remember this formula. Like here area is A, here area is AP, here area is AQ, here velocity is V, VP and VQ. It is given. Then from equation of continuity, it is that A into V is equal to AP VP plus AQ VQ. Okay, this is the formula from equation of continuity. Area into velocity will be same if you add together at a point. Then A into V, area into dx by dt. Area into dx, can I say volume, change in volume? So this will be dv by dt. That is given here. Rate of liquid flowing 0.1 meter cube per second. Okay, so this is given as 0.1. AP and AQ are given. A value is also provided. Then AP given, AQ given, then VP is also given. Only VQ you have to find. Substitute the values, you will get VQ. It is actually equal to 30 meter per second. Is it clear? Second
step.
This one, A into V from LHS side I am taking. Velocity I am writing as dx by dt. Dx is like change in length, okay. So this is area, this will be dx. So area into that distance will be volume, that small volume, right? That I am writing as dv. So this will become dv by dt. dv by dt is liquid, amount of liquid flowing per minute. That is given in the question. Liquid flowing per second is 0.1 meter cube per second. See, it will be meter cube per second only. So this is the value given in the question. So we can equate in the LHS side. Now is it clear? Okay. Next question. You are asked to design a shaving mirror assuming that person keeps it at 10 centimeter from the face and views a magnified image of face at 25 centimeter. Radius of curvature of mirror. We know radius of curvature of mirror is nothing but 2f. Okay, you have to find f only. And from mirror formula, 1 by v plus 1 by u equal to 1 by f. U is given as 10 centimeter. So if this is a concave mirror at 10 centimeter, what is there? Or you can draw in a normal way. Okay, this is concave mirror at 10 centimeter is the person. So U is that. Now if the like object is placed between pole and the focus of the mirror, you will get virtual erect magnified image behind the mirror, right? So at 25 centimeter, he needs to see the image. If we are taking like concave mirror and this side image, 25 will be behind him. He cannot see that. So it will be in front only. So from this, V is equal to 25 minus 10, 15 centimeter. So U equal to minus 10 centimeter, V equal to 15 centimeter. Substitute this, you will find F, multiply it with 2, you will get R. Since it is facing this side, it will be minus 60 centimeter. Is there any doubt? Okay. Coming to next question. The position time graph is given. Mass is 2 kg. You have to find the impulse of body at t equal to 4. I told you what is impulse. Impulse is nothing but change in momentum. You have to find momentum at like just before reaching this point and just after. Okay, this region, what does this mean? Position is not changing with respect to time, which means the body stopped. Body stopped. Final momentum will be, final momentum is equal to 0 because body is not moving. Initial momentum you have to find, that is equal to mass into velocity. Mass is given. Velocity how can we find? That is equal to dx by dt. If you are finding dx by dt, that is equal to 3 by 4. So m into 3 by 4 will be final momentum. So initial momentum there, final momentum there, just find the difference, you will get impulse. Since 0 minus is coming, negative value will be the momentum, like impulse. Negative value only 1 is there, so like that also you can take, no need of calculation also. Is it clear? Is there any doubt in this question? Otherwise we can move to the next one. 2 more questions I think we can solve. Okay, next one, terminal velocity of ball depends on. Terminal velocity equation is 2 by 9 rho minus sigma r square g by eta. It either depends on viscosity of fluid or radius of the ball or change in density. In this option only difference in density is given. Viscosity and r is not mentioned. So we can say option D. Okay. I hope 37 is clear for all. Coming to 38, angle of incidence at which reflected light is totally polarized for reflection from air to glass. This is Malus law. Okay, it just says that like when like polarization is happening, this is n1 sin I equal to n2 sin r. This is our Snell's law. Okay, then when this is polarization is happening, this is equal to cos I. Okay, when polarization is happening, sin r is equal to pi by 2 plus I. So sin of pi by 2 plus I is equal to cos I. Okay, so you will get sin I by cos I equal to n2 by n1. So from air to glass it is moving. n1 is air, n2 is glass. Air is having 1, so we can say it is equal to n. Sin I by cos I, tan I equal to n, I equal to tan inverse n. Answer option D. Is it clear? So always start from Snell's law like this, okay, so that you won't get confused like n2 by n1 or n1 by n2. Not got. This is directly from Malus law. Okay, so if the light is completely polarized, like this is glass, this is air, in incident one, this is reflected one also I, this is refracted, okay, R. When the reflected light is completely polarized, our condition is this will be at 90 degrees, okay, and finding that we will get R equal to actually 90 minus I, okay, R equal to 90 minus I you will get, okay. So sin R equal to sin of 90 minus I equal to cos R. Substituting that you will get this one, cos I. Is it clear now? This is the condition for polarization. Okay, like we are not taking randomly. Condition for polarization is that reflected ray and refracted ray will be having 90-degree difference. Like from geometry, then we can get R equal to 90 minus I. Can we move to the next question? Okay. A steel ball of mass m is moving with kinetic energy k, de Broglie wavelength. De Broglie wavelength equation, h by p, p is equal to root 2 mk, p square by 2m equal to kinetic energy. So our answer is option D, h by, sorry, not B, h by root 2 mk, option C. Okay, de Broglie wavelength. Now 5 more questions. I don't know if we have time. Like, should I continue for next 5 questions or can we stop here? Okay. Okay, coming to next question number 40. Alpha particle of energy 5 MeV is given, scattered 180 degree by uranium nucleus. Distance of closest approach. Distance of closest approach you can get by equating kinetic energy equal to potential energy. Kinetic energy already given. Potential energy we have to find. Potential energy how we will get? U equal to K Q1 Q2 by R square. This R is distance of closest approach, not R square, R. Okay. This R is distance of closest approach. This one we have to find. So R will be equal to K Q1 Q2 by kinetic energy. Okay, kinetic energy is given, that we can substitute. Now K is equal to 9 into 10 to the power 9. Q1, let's take charge of alpha particle. Charge of alpha particle is plus 2e. Okay, so 2e, and charge of uranium atom, like atomic number is 92, so 92e divided by, it is given in MeV, so we have to convert it to joule. So 5 into 10 to the power 6 electron volt converting to joule, multiply with E. So 1 E will get cancelled. First you substitute, you can find the like approximate range only we need. We don't need the exact value, approximate range only we need. Okay, so you will get answer 10 to the power 12 approximately. Okay, is it clear? Okay, moving on to next one. Mass of lithium nucleus is this much less than sum of all mass of nucleons, and binding energy per nucleon you have to find. Okay, binding energy per nucleon you have to find. This much less means total mass we don't need. For finding binding energy is just delta m c square, so we don't need to find the other mass. And since it is given in U, we have a direct formula, that is delta m whatever is given into 931 MeV will be binding energy. So if mass defect is given in atomic mass unit, you can multiply with 931 and you will get the energy, okay, in mega electron volt. But they are asking energy per nucleon. Binding energy per nucleon is Be divided by mass number. Okay, Be by mass number will be binding energy per nucleon. So 0.042 into 931 into 10 to the power 6 eV divide, okay, it is in mega electron volt only. So 931 divided by atomic number is 7, this much MeV will be the answer. Option B. Okay, is it clear? Okay. Next, 42. In the given circuit, calculate voltage across A and B. These and all we don't need much calculation. Okay, see here, this is positive. So this diode will be forward bias. This diode will be reverse bias. So there will be no current passing through this. Okay, since it is forward bias, we can short the diode. This will be simply like two capacitors connected in series. Since both are having same C, it will be having same like V same only, right? Like two things, it will be splitting the volt between them, and both are having same C means it will split equally. So answer is option C. Okay. Next one, an organ pipe. Okay, this one I am not discussing because you need like waves chapter. After SHM I will discuss this one. Okay, we need like fundamental frequency of organ pipe for so that one I am not discussing. The value of smallest division, this one means from units and measurements we know this. So N VSD equal to N minus 1 MSD. First one we will get. Then 1 MSD is equal to 1 millimeter. Vernier constant is nothing but least count. Least count is equal to 1 MSD minus 1 VSD. Substitute VSD from this, then put 1 MSD equal to 1 millimeter. You will get the answer. It is equal to 1 by N. Okay. One more last question. Is this one clear for all 44? Okay. Last one. Okay, Fermi level is the like where like 50% of finding an electron. That is what Fermi level means. Okay. For intrinsic semiconductor, Fermi level will be in between valence band and conduction band. So A2 there are two options, C and D. Then coming to metals it will be like all options same only, so we don't have to consider. Then N type and P type only we need to see. N type Fermi level will be near valence band. Okay, so B is 1, answer is option D. Okay, like that. And for P, Fermi level will be near conduction band. Okay, this we will discuss while discussing chapter semiconductor. I hope that's fine for all. If there is no other doubts means you guys can leave. Thank you all. Join at 12